You stand up. The baby is quiet. You sit down. The crying starts all over again. Every new parent has experienced this exact maddening cycle. In the dead of night, with your back aching and your eyes heavy, you probably think your baby is just being stubborn, right? Or maybe they just want to be held. But wait, what if I told you that your little one isn't throwing a tantrum at all? What if right in that exact moment, your baby is actually experiencing a primal fear of death? Science reveals that when you sit down with your crying baby, a literal danger alarm goes off inside their brain. Behind this strange, a universal magic trick of standing up to calm a baby lies a very dark biological secret. A secret directly connected to human evolution, prehistoric survival, and terrifying apex predators. Today, we are looking at the hard neuroscience and evolutionary biology behind why babies instantly stop crying the moment you walk. By the end of this video, you will understand your baby's brain on a completely different and deeply fascinating level. Let us get straight to the science, starting with a myth that needs to be destroyed. Sleep-deprived parents are constantly told by older generations that carrying a crying baby will spoil them. You are warned that the baby is manipulating you into holding them, and that you should just put them down and let them cry it out. Neurologically speaking, this is entirely impossible. To manipulate another human being, you need a highly developed prefrontal cortex. That is the area of the brain responsible for complex planning, deception, cause and effect reasoning, and forward thinking. In a human infant, especially in the first 6 months of life, the prefrontal cortex is almost completely unformed. They physically do not possess the brain circuitry required to manipulate you. They are not plotting against you. So, if it is not a behavioral trick or a learned habit, what exactly is happening inside their tiny bodies on a biological level? Biologists refer to this phenomenon as the transport response, and it is not a conscious choice. It is a deeply ingrained autonomic nervous system reflex. For decades, pediatricians simply assumed that walking calmed babies down because it mimicked the gentle, rocking motion of the mother's womb. While there is some truth to the comfort of the womb, that hypothesis completely failed to explain the rapid, almost mechanical speed at which a screaming baby shuts down the millisecond a parent stands up. In 2013, a groundbreaking study published in the journal Current Biology finally decoded this mystery. A dedicated team of neuroscientists at the Riken Brain Science Institute in Japan, led by Dr. Kumi Kuroda, conducted a highly controlled, incredibly revealing experiment. The researchers attached tiny, harmless electrocardiograms, or ECG monitors, to human infants to measure their heart rate variability in real time. They carefully monitored the babies while their mothers sat down holding them, while they stood up, and while they walked across the room. The data that came back from the monitors was absolutely shocking. The exact millisecond the mother stood up and began a rhythmic walking motion, the baby's parasympathetic nervous system rapidly engaged. The parasympathetic nervous system is the body's rest and digest network, responsible for calming the body down after periods of intense stress. It instantly lowered the infant's heart rate. But the physiological changes did not stop there. The study found that vocalization, or crying, dropped by literally 100%. Furthermore, all voluntary muscle movement ceased entirely. The babies went completely limp, entering a state of physiological bradycardia, which is a sudden, natural slowing of the heart rate. The researchers noted a crucial detail. This was not the baby deciding to take a break from crying. It was an involuntary, primitive reflex, triggered simultaneously by the mother's body heat, the physical grasp of her arms, and most importantly, the vestibular stimulation of walking. To truly understand why the physical act of walking triggers this automatic off switch, we have to look deep inside the baby's inner ear. Deep inside the human ear is the vestibular system. It is a highly complex network of fluid-filled canals that acts as the body's internal gyroscope. It tells the brain exactly where the body is in space and how it is interacting with the forces of gravity. When you are sitting in a chair holding your baby, the vestibular system registers that the body is stationary. It knows you are not moving. But the moment you stand up and begin to pace the floor, you create a rhythmic oscillation. You are essentially bouncing up and down at a specific frequency of about 2 Hz, which translates to roughly 2 steps per second. The baby's vestibular system instantly detects this 2 Hz frequency. It sends a lightning-fast electrical signal to the cerebellum, which is the part of the brain that controls motor movement and physical coordination. The cerebellum then sends a strict, overriding command down the spinal cord. That command is simple. Halt all crying, relax all skeletal muscles, conserve energy immediately. This neurological chain reaction is fascinating, but it begs a much larger, more terrifying question. Why did human biology evolve to have this specific trigger? Why does walking equal silence? This is where the science takes a very dark prehistoric turn. To find the answer, evolutionary biologists tell us to look back at the Pleistocene epoch, tens of thousands of years ago. Early Homo sapiens were nomadic hunter-gatherers. We lived in open savannas, rugged mountains, and dense forests. We did not have walls of brick and mortar. We did not have locked doors or advanced weaponry. We were constantly surrounded by massive, hyper-aggressive apex predators. Saber-toothed cats, dire wolves, giant hyenas, and massive cave bears roamed the exact same hunting grounds that we did. In that brutal, unforgiving environment, survival was a daily, terrifying challenge. That humans were not always the hunters. Quite often, we were the prey. Imagine a prehistoric mother sleeping on the hard ground with her newborn infant clutched to her chest. Suddenly, the brush rustles in the dark. The unmistakable scent of a stalking predator fills the night air. The mother's sympathetic nervous system, her primal fight-or-flight response, is triggered in a fraction of a second. She cannot fight a cave lion. She has to grab her baby and run for her life in the pitch black. In a frantic, life-or-death pursuit through a dark, silent jungle, what is the single greatest threat to the survival of that mother and her child? The baby's cry. A screaming, crying infant would act as a biological homing beacon for a hungry predator. It would guide the animal directly to the fleeing mother and potentially compromise the hidden location of the entire sleeping human tribe. Through the brutal, unforgiving filter of natural selection, evolution solved this deadly problem. Over thousands of generations, babies who kept screaming and thrashing while their mothers frantically ran away were easily found by predators, and they were eliminated from the gene pool. The babies who survived to pass on their DNA were the ones who possessed a brilliant genetic mutation, a brain that forced them to shut down, go limp, and remain dead silent the exact moment they were picked up and carried away. You might be wondering, do other animals possess this same survival trait? Yes, they do. The transport response is highly conserved across many mammalian species. If you pick up a mouse pup by the scruff of its neck, or if you watch a lioness carry her cub in her mouth, the infant animals immediately fold their legs inward, drop their heart rate, and go completely limp. But the evolutionary stakes for human beings were uniquely high because of one major, defining anatomical difference: bipedalism. Unlike monkeys, gorillas, or chimpanzees, humans walk upright on two legs. A baby chimpanzee is born with strong hands and prehensile feet, so it can physically grasp its mother's thick fur and hold on tight by itself, leaving the mother's arms completely free to climb trees or swing away from terrestrial danger. Human babies, however, are born completely hairless, with virtually zero grip strength, and they are incredibly heavy compared to the mother's body size. Because human mothers walk upright, they must use their arms and hands to carry the infant. If a prehistoric mother is sprinting away from a predator over rocky, uneven terrain in the dark, a thrashing, kicking, screaming baby would completely destroy her center of gravity. The shifting weight would cause her to trip, fall, and ultimately, they would both perish. Therefore, the human baby's brain evolved to be the ultimate survival co-pilot. By going completely limp, dropping its heart rate, and remaining dead silent, the baby makes itself as aerodynamic, compact, and easy to carry as a sack of flour. This biological reflex maximizes the mother's physical balance, drastically increasing her chances of outrunning the threat. There is yet another layer of fascinating science that makes this even more intense for modern parents to deal with. It is the biological concept of altricial development. In the animal kingdom, precocial animals are born highly developed. A baby horse or a baby giraffe can stand up on its own four legs and run from predators within hours of being born. Stiliki. But human babies are incredibly altricial. They are born utterly helpless, neurologically raw, and physically underdeveloped. Why? Because human evolution prioritized two conflicting things: a massive brain size and walking upright. Walking upright required human females to develop a narrower, more specialized pelvis. But simultaneously, human brains were expanding in size to accommodate higher intelligence. To solve this dangerous biological paradox, human babies have to be born relatively early, long before their skulls get too large to safely pass through the birth canal. Renowned pediatricians refer to the first 3 to 4 months of human life as the fourth trimester. Your baby's brain is simply not ready for the outside world yet. They are still desperately craving the sensory environment of the womb, which was incredibly loud, tightly compressed, and constantly in rhythmic motion as the mother walked around all day. So, when you place your newborn baby flat on their back in a completely silent, perfectly stationary crib, to their primitive, underdeveloped brain, it feels like they have been abandoned in the wild. The danger alarm sounds, their heart rate spikes, and they scream to summon you back to protect them. This deep, ancient evolutionary programming is exactly why the magic breaks the very second you sit back down in your chair. Your modern house is perfectly safe. The doors are locked, the temperature is regulated, there are no cave lions outside. But your baby's nervous system does not know what a house is. Their DNA still thinks they are sleeping in the Pleistocene jungle. When you are walking with them in your arms, the brain calculates, okay, mom is moving. We are escaping the danger. Keep quiet. But the millisecond your body weight hits the couch, the rhythmic vestibular stimulation stops. The primitive brain panics. It calculates, wait, why did we stop? The predator might still be out there. We are exposed and vulnerable. I cry immediately so mom will stand back up and keep running. So how do we use this hard science to survive the newborn phase without breaking our backs or losing our minds? We have to smartly hack the baby's primitive nervous system. First, you must embrace ergonomic baby wearing. Using a tight, high-quality fabric wrap engages the baby's proprioceptive system, which is their internal sense of body awareness. It mimics the tight, warm compression of the womb, keeps their body physically connected to your heat signature, and allows you to simulate the walking motion as you do light chores without completely burning out your arms and shoulders. Second, master the art of vertical oscillation. You don't always have to relentlessly pace the hallways at 3 a.m. You can trick the vestibular system by sitting on a large inflatable yoga or exercise ball. Gently bouncing up and down at that specific 2 Hz frequency provides the exact rhythmic, vertical motion the cerebellum needs to keep the danger alarm turned off, while saving your legs from total exhaustion. Third, utilize the 5-minute transfer protocol. The researchers at the Riken Institute actually formulated a specific exit strategy for exhausted parents. They found through their ECG data that parents who walked for exactly 5 to 8 minutes successfully pushed the baby's brain from a light, alert sleep into a much deeper, slow-wave sleep state, SATR. If you try to put the baby down immediately after they stop crying, the sudden, jarring change in gravity will wake them up. You must walk for 5 solid minutes, then sit down and hold them for another 5 minutes to stabilize the heart rate, and only then slowly transfer them to the crib. Parenting is an exhausting, beautiful collision between millions of years of ancient evolutionary biology and the structural demands of our modern, fast-paced world. Your baby is not a manipulator. They are not trying to ruin your sleep. They are a brilliant, primitive survivor, relying entirely on instincts forged in a terrifying world long before recorded history began. When they cry upon being put down, they are not fighting you. They are simply asking for your warmth, your movement, and your protection from the invisible predators in the dark. If this deep dive into the neuroscience and evolutionary biology of parenting changed the way you look at your baby's behavior, hit the like button right now to help the YouTube algorithm spread this science to others. Please share this video with any new parent you know who is currently running on zero sleep. It might just save their sanity and their back. Let me know in the comments below, how long did you have to walk your baby to get them to sleep? And did you ever try the yoga ball trick to survive the nights? Subscribe to the channel for more dark scientific truths behind human behavior. Until next time, stay curious and take care of yourselves.